GM and welcome to another Solana tutorial. Today we're gonna talk about signing messages. Specifically, what that even is, how it works, how it differs from signing transactions, pretty important one, what signing messages is used for, and then also why you should probably not sign any random message. That's the premise. Let's get started. Alrighty. I want to start with showing you what I mean with message signing, and the Solana dApp scaffold has some message signing in that basics component. Learning 1. To sign messages, you actually need a wallet. Okay, let's get ourselves a wallet. MSG, message sig. Yeah, we'll take that. Message signer. New key pair, doesn't have any funds on it. But lesson 2, we don't need funds to sign messages. Let's connect. The standard wallet connects to site, which is not the same as Solana sign-in, but we might talk about that in the very end. I imagine that Solana sign-in just combines this step with signing a message, but I haven't actually looked at it. Maybe we'll do that later. So we connect, and here we can now sign a message. Let's do that. Just so you see what that looks like. You've probably seen this before. It says sign message, and then it tells you the message it's signing and lets you sign or not. That's what the wallet does. The app says, hey, can you please make the wallet sign this message? And then the wallet displays it. And Phantom neatly also says, only confirm if you trust this website. So apparently signing also can be used for malicious purposes. But it's way safer, I'm going to say this right away, it's way safer than signing a random transaction. Because with a transaction, you can actually change the state on the Solana cluster, aka send SOL around or tokens or whatever. With a message, you cannot do that. Lesson 3. Haha. Anyway, we're getting ahead of ourselves already in minute 2. Messages also don't expire. They're pretty static. They don't have a block hash. So I can leave this window open for a very long time and it will never expire. It will also not change. And at some point, I can either cancel or sign or close the window, which also cancels it. So let's sign. And then boom, we've signed a message. This is now a signature that we get. However, even if we have a look on the block explorer, that signature is not found because it wasn't used to change a state. Like it wasn't a signed transaction that was then submitted. It was just a signature that was created. That's it. Just for comparison, let's also click on sign transaction. Oh yeah, and that won't work because I don't have any funds. Okay. The point is here it says confirm transaction, and lets me confirm a transaction and not just sign. Okay, let's have a look at what's happening in the background here. So it gets the sign message from the use wallet hook that is in the Solana wallet adapter, and then literally all it does is it calls that sign message with a message, which is just some encoded text. So it even gets a text encoder here. Where's that from? Class is a global reference of require util. Okay, so that seems to be a TypeScript thing or a JavaScript thing. Basically, we just want to encode special characters and we want to get from some string to some byte array. Because again, also when we have transactions and we sign them, then we first encode the transaction to get the raw transaction, so just the bytes of the transaction, the serialized transaction, and then we sign those bytes. Because what signing actually does is just it takes the input bytes and performs some private public key cryptography on it. So with the private key, it signs those bytes. And then with the public key, you can verify that the signature comes from that private key. That's what we do here. The verify, which is just an ED25519. So that's the curve that is used for cryptography. That's not a Solana package. That's just elliptic curve cryptography stuff, with which we can verify that the signature actually is a valid signature for the given message from the given key. So for signing, we need the private key. For verifying, we need the public key. and of course the same message. If the message is different, then the signature will be different. And we're gonna have a look at that in a second. But for now, just see that this thing, if the signature wouldn't have verified, then we wouldn't have gotten the signed message successful and the base 58 encoding of the signature. So that looks pretty much the same as a signed transaction, right? A transaction signature, but it's not. It's just a message signature. Now, this could be confusing in terminology because a transaction also has the message part, which is the part of the transaction that we actually sign. And then we add the signatures that makes up the entire transaction then. So message is just the thing that we sign. And for signed message, the message is different than for signed transaction, where the message part gets signed. But the message for signed message is actually more than just the message. So let's have a look at that. Oh man, this is already getting confusing, huh? Anyway, to get it a bit less confusing, let's remove all of that front end blah blah, abstract that away and just work with key pairs. Because I don't want to always have to click here to sign a message. Kill that, I don't need that. And let's just do a... Okay, so I just loaded my key pair from a file. And usually when we want to send transactions, we would get a connection now. But I think for signing messages, we don't need a connection. I would expect that the key pair actually... No, the key pair doesn't have a signed message. Okay, how would I sign? Actually never done this before, so we'll figure it out. Lol, more difficult than I thought. Somebody asked that on Stack Exchange. There we go, how to sign message in Solana Web 3. So it seems like they're actually doing that manually with those libraries. That doesn't seem to be a clean way to do it with Web3.js. Apparently that's not a use case that you need often, which is weird. How to sign and verify messages with wallets. Yep, Cookbook also says that's the way to do it. So let's do it. Such that it's getting complicated rather quickly for you. I'm gonna make myself a sign message with a message and a key pair signer. And we will need this library. So npm I tweetnackle. Import what you got. The sign, we got the verify. The decoding, I'm just gonna do the same way they did here with the text decoder. I'm pretty sure that that's the same thing. And then signer secret key. That's how we sign. And the signature is then a uint8 array. Verify, we'll do the same thing. We decode the message. And I'm gonna do signatures as base 58 because that's what we're used to. So with the sign, I'm gonna return the base 58 encoded signature and not just the bytes. And the other way around, here I'm gonna decode back to bytes. Okay, so I now manually build those two functions and use this package to do the actual signing. Right, okay. A bit more complicated than I thought. I thought those two I would find somewhere in Solana Web 3, but okay, never mind. Let's actually do some message signing. Because this, spoiler alert, is not actually the same as the sign message like here. It does more stuff. But before we look into it, let's pretend it was and then find out that it isn't, such that we learn something. Okay, let's sign a message. My message is, please sign this. And then my signature is sign message, this message, and sign it with my key pair. And then we just log the signature. That's all we do for now. Simple message signing. Cool, we get a signature. We don't actually know if that is the real thing or if that's just random bytes that we encoded in base 58 and that's that. So what we can now do with that signature is to prove that it's actually coming from that key pair without having the key pair. But maybe one more important thing here, of course, when I sign again the same message with the same key pair, it will be the same signature. This stuff is deterministic. It has to be. So I sign again, I'll get the exact same signature. And the exact same big int error. That annoys me. Okay, so now let's verify. Verify message. This signature Was it from the message and the key pair's public key? Note how we only need the public key here. We don't need to provide the private key for verifying, obviously, because the dApp will not have the private key to check, but it has the public key of the wallet. And with that, it can check if the signature is actually valid. Signature is valid. And we can now do some whatever stuff. I'm also logging the result down here, so I'll get the true and false anyway. Okay, so same signature again. Result is true. Signature is valid. If the message was something different, then obviously my signature verification would fail. There we go. Result is false. And this signature is not valid for this message. Also, if we have the same message but a different public key, so if we were to check if that signature is from someone else, then the verification would of course also fail. I can't tell if it's a different message or if it's a different key pair. I have no way of saying, right? The only information I have is this is not a valid signature. And I can't say what's wrong, right? I can't pin it down because the verify will just give me, it checks out. When it really checks out byte for byte, every single byte must match both from the key pair and the message. And otherwise I just get false. That's the same, by the way, with transactions. As soon as one byte somewhere flips, obviously the entire signature is false, and then the signature verification will discard the transaction. Signature verification failed. Now, so far so good, but couldn't we just also use this for signing transactions? The answer is yes. And I'm gonna make it a bit easier for myself at the send transaction where I just transfer Lampert's. You know what? I need some funds. Can I have an airdrop, please? Thank you. So I'm building a transaction where I just send 0.0001 sol to some random address with the current block hash. And that transaction, before I sign it, actually the message would already be enough. I'm gonna just serialize myself the message and then also decode that somehow. Or actually, I don't even need to decode it. I'm just gonna log it. Let's save that step. Let's just log this byte array. I mean, it would be nicer if I were to encode it and then decode it again. I could also encode it in base 64 or whatever. It doesn't really matter, as long as I then decode it with the same strategy, with the same encoding. Video on encodings, right here. Ugh. By now you've seen it, right? I guess so. Okay, then I also let the user sign the transaction, and I'm also gonna log myself the signature. That's what we then need. So, okay, let's do it. Gotta actually start up that thing again. So this is now the message part of a transaction. So that's what, when we're signing transactions, we would actually sign. So let's send that version transaction. Oh, I need to go to DevNet, otherwise block hash expired. Yeah, hold on. Block hash just not found because we have different block hashes on DevNet, of course. There. Okay, one more time. On DevNet this time. I do have funds now, so the simulation should actually succeed. Yes, so a normal confirmed transaction as we know it, I can confirm it and then it will actually perform that. And I will get a signature. There we go. And this now actually hit the cluster and I can find it on Explorer. That's an actual transaction with that signature, 4T78. Remember that. Because my question is now, given the same message, so there is a lot of red, but the important stuff is here. So this one, those bytes, you know, just some bytes of a uint8 array, that thing I've encoded in base 58 to those bytes, and then signing that message gave me that signature. So that thing that represents the message of the transaction, if I sign it, gives me that signature, and with that signature, the validators accept that transaction. But what if I were to sign the same thing here with my key pair? Again, same key pair that I have in my wallet, that's also important. So what if my message, this is the encoded message that I just copied, and then the raw message I just decode from that. So again, this should now give me the same bytes. I'm gonna lock that and check. This should now give me the same bytes as we had here, 128.101. Yep, 128, that's 18 hex, 101. Same bytes, it's just decoded from here. And then we do the same thing, just that this time my message will be the raw message, so I don't go via text. Sign raw message with a uint8 array. And then I don't need that part. I just sign those bytes. We just extracted one step with the encoding of the text because we don't want the text message, but the raw one. We can do the same thing for verify raw. So always just the text encoding we moved out. Anyway, point is I can now sign raw message, put in the raw message and get a signature. And then the verify, same, I can verify the raw message as well. So now I'm actually curious if that would give me the same signature as the properly signed transaction. Because I would kind of expect that yes, it would. But no, it doesn't. It doesn't even check out. Oh, wait, hold on. First of all, this should be my key pair again. But this is then always difficult to debug because I just get a, it's not the same and I don't know why. Oh, well, okay, no, hold on. This is true now, but this is different to what I got earlier. Maybe I do need more than just a message to sign. Shit, the video is gonna get long again. To compare, let's try something different. Let's try signing it here. Let's make a version transaction with this raw message. On the version transaction, I should be able to sign. Transaction should have a sign. Yeah, there we go. Haha. Don't need a connection or anything. So I sign with my key pair, and then I get the signature from the transaction. Signatures, the first one, because there's only one signer. And I'm gonna again decode that or encode that in base 58, because that's how we like to look at our signatures, not in bytes, but in base 58 encoding. Log this signature as well and see how that is different, if that is different. No, actually, this is the exact same. Nice. Okay, we're getting somewhere. If I sign that raw message with my function, the sign raw message, that basically just calls this, I get the same signature as if I were to build a version transaction, sign that, and then get the signature from there. So that does the exact same thing. Now my question is still, why did the message not, like, I would expect the same signature as we had, you know, here. Maybe something with the message decoding went wrong. That is mega weird. So that's the transaction that I would be signing. I confirm that, and that's the signature I get. And that's the confirmed signature I get, 2xc. If I put that in here, I do get a different signature. Ah, this is annoying. If something is not working the way I want it to, this is annoying. Can try deserializing the entire version transaction. Do you think that will make a difference? Should have the same public key, the same block hash, the same instructions. So this is the message and this is the transaction. If I sign it, I get that signature. If I get the transaction, deserialize it, you get that message. You still both get the same signature, but it doesn't correspond with the actual signature. What the hell? Hold on. Give me a break. Phantom. Is this on you? Phantom, because wallets sometimes do tricks on me. Yeah. Okay. Well, obviously. Oh man, you and that took me half an hour of my life. Okay, so man, because Phantom doesn't actually sign the thing that I give it to sign. No, Phantom is being smart. It adds, by the way, that's not just Phantom, that other wallets do that too. I just happen to use Phantom. It adds 2 instructions to the compute unit program. And then of course, if you change the instructions, then you change the message, thereby changing the signature. Okay, fair enough. So, Phantom does that, and this is again a deep dive into a completely different topic that is actually not the topic of today, but since we're handling it, we might as well discuss it. So, Phantom or other wallets are doing that if the transaction I'm giving it has not been pre-signed already. Because if there's another signature, then obviously they can't change anything because then the other signature wouldn't be valid. And if adding the instructions would not blow up the transaction over the transaction size limit. So I could build a transaction that is so big that you can't do that anymore, Phantom. Or I provide compute unit instructions myself to the compute budget program. So that's what we're going to do. I'm going to manually tell you what you should put there, and then you won't mess with it. Man, and I debug this for hours. Okay, but at least I found out. Sorry for wasting all of our time. But hey, at least we learned something about it. So it takes me a bit longer to make that point, but we'll make that point. Here, compute budget program, set compute unit limit to the standard 200K. By the way, made a video on compute where we discuss exactly that. So that's the one thing. And the other thing, set the price. I don't want no priority fee. Phantom, stop it. Stop adding stupid other instructions that I don't want to sign. Okay. But now, if we now send a version transaction, this time with the actual instructions that I provided, so those instructions are now the same that I provided, and I confirm that, I get the signature 5JN up. Remember that. So that's also a confirmed transaction now. I find that on the Explorer. I did sign it and it went through. So now let's grab this message. That message now includes those compute budget program instructions as well. And if I sign that, throw your hands in the air and say, oh yeah, that's the same. It's the same. 5J and up. Yes. Okay. Whew. I love it when stuff works. And I expected that to work from the beginning. Thank you, Phantom, for wasting my time. No, actually, it probably makes sense what you're doing. But like for a power user like me, it sometimes is confusing, all this special stuff that you do. Because I don't see why you would need to add that unless the network is actually congested. Or unless there's actually an attack error. But yeah, Phantom prioritizes usability over saving money or being nice to devs. So point here is, and that took me a bit longer to make that point, but I'm making that point, that if I provide the message of a transaction to my nice little sign raw message function that signs this thing, with elliptic curve cryptography with that private key, then I get the same signature. So this stuff can be used to sign transactions. I use that message, put the signature into the version transaction, and then I could send the transaction to the cluster and it would accept it, provided that the block hash would still be valid or I'm using a nonce transaction. Then I could do it like that. So that's the same thing that is used for sending transactions. We sign a message and put it in a transaction and then submit that. So how is that now different from signing messages? And didn't I already say that signing messages is safer than signing transactions? How is that the case if when signing a message, you can do the exact same thing as sign a transaction? If you're confused now, perfect. Because now starts the point where we learn. Because let's do the same thing with actually message signing. So back to just signing a text message. Please sign this. I'm gonna let the sign message thing sign the same thing. Please sign this. And then I'm waiting for it to compile. Gonna also lock the signatures. All right, waiting for a refresh. Perfect. Now I sign a message. Phantom, did I annoy you too much? I'm sorry, Phantom. I'm gonna be nice again. Come on, come back. Phantom, where are you? Okay, fine, I'll refresh the page. Short videos, it just doesn't work for me. Cool, so sign message. Thank you, Phantom. Please sign this is the message. And if I sign this, then I get this signature. Oh, I forgot to encode it. So anyway, this signature, V1Q3. Let's log it one more time, but encode it. Because remember, signing messages, if I sign the same message, like here, sign the same message, I get the same signature. There we have it, V1. That's also why we include block hashes in the transactions, such that something changes, such that my signature is not valid for very long. And when applications use the signed transaction, then they usually put some kind of timestamp or nonce into the message, such that the signature always changes. And I can't, save the signature and replay it later. Okay, so V1Q3. But how was that again when I was just doing my signing with my message here. What signature do I get now? V1Q3. The same one. What? You for real? You're messing with me again. I had a mental model of how stuff works. Really? Are you sure? Are you sure I should get the same signature here? Oh, ouch. Did I find another vulnerability? Maybe. That is not good. That is not good at all. Why is that the same? Shit. See, I would have expected this to be different, but it's the same. Ah, help. Oh no, oh no, oh no, this is bad, this is bad. If you're not as concerned as I am right now, I guess that's okay. Because either I'm making a huge mistake or the implementation of the sign message really doesn't do what I expect it to do and what I deem as safe. So there we have it, yet another exploit. Let's try something different, because obviously it shouldn't matter which wallet I'm signing with. I'm gonna import the same key pair here. Gonna disconnect this wallet. Solflare! You are so annoying. Every freaking time I need to get the Solflare wallet adapter in here manually because you don't support that stupid standard. I mean, I get why, again, if you want that alpha, they don't support that because that would then not work with their web app, and a lot of their customers use just the web app. And that would be bad if that wasn't supported. That's why Solflare is like, hey, please always include that adapter, which I can understand, but it's still annoying. If I just want to use that thing, then thank you. Anyhow, if I now sign message with Solflare, let's see if we get a different signature. That would be really fun. So we get, please sign this as a message. Signing a message proves wallet ownership. It's not an on-chain transaction and incurs no network fees. Yes, that is true, or should be true. Now, let's approve this. V1Q3. Wow. Damn! What the hell? Okay, I'm gonna teach you why this is bothering me. Solana sign message specification. There. Off-chain message signing. That's what I'm searching for. Off-chain message signing. Non-transaction messages. This is important. Non-transaction messages with a Solana wallet to authenticate users or provide proof of wallet ownership. Exactly. So, authentication and just proving wallet ownership. By signing, you should just prove that you own it, but it shouldn't be able to do anything with it, right? It shouldn't be able to send a transaction based off your signature. That's the idea. Okay, and here comes the interesting part and the important part that my head currently covers. Check this out. To ensure that off-chain messages are not valid transactions, they are encoded with a fixed prefix. /x means it's that the next thing is hex, and then FF, so that means it's a 255 byte. And then Solana off-chain, where the first byte is chosen such that it is implicitly illegal as the first byte in a transaction. Message header. More about payload formats in this proposal. So this is important. Every message for the off-chain signing has or should have this prefix where it starts with a byte 255, which is not a legal first byte in a transaction. And the first byte in the message is in the header, and the first one is the number of required signatures. So the required signatures would be 255. That is apparently first of all, illegal, and secondly, you can't provide that many signatures. Okay, so essentially, if we have this in our message as a prefix, then it should never become a valid transaction. And this thing is now confusing me so much as to why I still get the same thing, because that is the same thing as if I would not have this prefix, because I never have this prefix. There is no XFF Solana off-chain prefix in my message. So I'm concerned. One more time. Happens way too many times here. Okay, let's try something. You said Solana sign off-chain message. Solana doesn't have that. What are those docs? docs.solana.com. Seems like a pretty legit site. Do I find that anywhere else? Wow, I would not have thought that this video would get me so confused. I thought it would be a simple video. Hey, look, that's the difference between signing a transaction and signing just a message. So signing messages is relatively safe. Okay, since I can find zero proof that this is actually the case, and I can't get that to work either, we're gonna pivot and make this video about something completely different. Namely, can you spoof transactions with signing messages? Because with my current experimentation, I would argue, yes, you can. Before I was like, no, you cannot because of this thing. But this thing, nobody seems to adhere to that anyway. So might as well sign a transaction with the message signing. Let's try that. And if that works, then I'm going to be way more careful when signing messages in the future. And we're here to learn. So let's go. I mean, essentially, all I need to change is instead of the send transaction, I'm gonna sign a message, lol. And there, I'm not gonna send no transaction, but I'm gonna sign a message, which needs the uint8 array. So essentially just the serialized message. You come back with a signature, raw signature. Actual signature is then the encoded raw signature, and then we just need to manually put in the signature into the transaction. Add a signature for my pub key, a raw signature. There we go, freaking easy. Let's go. Why not? And then we confirm that transaction. Wait, no, we actually, before we can confirm that transaction, we might want to send it. So send raw transaction. Now we're just gonna take our transaction and serialize it. And again, we should get the same signature. Let's also log that. That should be the same, but we'll see. And then we confirm it, and then we say success. Okay, start that up again. I would be at that point not even surprised if that would work, but highly concerned if that would work. Okay, send a versioned transaction. Here it says approve transaction, which gives me the simulation. So that's sending a transaction, right? That's a approved transaction, and it simulates it even. Approve. Interesting. So even though I called a sign message, it was treated like a transaction. Okay, so that's better. Okay. Good. So that's a wallet thing. Does Phantom do the same thing? No. Phantom, okay, apparently Solflare is smarter than Phantom. Look at Phantom being like, check this out. This is a message that you should sign. I mean, if the user sees that, they're gonna be like, what does that mean? But then on the other hand, signing is pretty safe, right? To prove that you have ownership of the selected account, that is safe. I don't need to freaking bother, and there's no simulation of that, so it seems safe, right? I mean, the application has some weird characters in their message, but right, I mean, you don't need just take, I mean, I'm just gonna sign this. Then the transaction signature verification failed. Okay, that's good. That's actually good. Funny how different wallets treat that stuff differently. Transaction signature verification failed. Probably here when I send a raw transaction. Wait, but earlier with Solflare it worked. Backpack. Oh man, Backpack. You're my favorite wallet. I gotta tell you, you're my favorite wallet as a hacker. Dude, Backpack just allows it. Backpack just pass it through. Yeah, sure. Sign a transaction with sign message. I don't care. Nice. Backpack, great job. Bad job. Bad Backpack. Why do you let users do that? Check that out. I can literally, with Backpack, sign a message where Backpack, I mean, see, if Backpack judges that, I mean, users should take care of that. I just approve a message, right? It's just approve message. It's not transaction. It's just approve message. This, yeah, whatever that means. Approve. And it actually gets sent. It's an actual transaction that actually gets sent because it doesn't adhere to the prefix. There is no prefix. I can actually send transactions just by signing messages. Wow, that's a very interesting and concerning finding. Because when I read up on that, that one time when I was building a wallet drainer, I was like, can I just use sign message and then actually have it be a transaction? And then I read that and I was like, okay, obviously not. But the documentation and the implementation seem to differ severely. Now, Phantom seems to still have some checks in place that the signature is not actually valid. Backpack lets me freaking sign a message that looks like this and it can be an actual transaction. This is too funny and should really not happen. Phantom for some reason also displays the same message, I think. Or not? Or does it add? Does Phantom add something? When I sign it, the transaction fails because the signature. I mean, software does it quite nicely in that when I call the sign message, they're actually just treating it as a signed transaction, approved transaction. I mean, it's like a signed transaction and not like a sent transaction, but they allow it. And then I can also actually send that transaction. I have Glow. Glow blocked this action as it may allow the site to take unauthorized actions on your behalf. That's actually not bad. And sign message. Please sign this. This won't create a transaction on the blockchain or incur a fee. That's cool. Glow does, in my opinion, the best job so far. Okay, I want to try something else. To make it consistent, just gonna put a static block hash, all zeros in here. Not because I want to actually be able to send that transaction, but because I don't want it to change, because I want to be able to compare signatures. Again, an approved transaction. It tells me approved transaction, even though it doesn't even have a valid block hash. But it simulates the part without the highly interesting. Highly interesting. I love it, actually. Approve. Transaction simulation failed. Block hash not found. Yes, that's what I would expect. But the signature was 5 EDKFF. And Backpack, where it would actually work, it's a completely different signature again. Why is it still a different message? What the? Different again, different again, different again, different again. Why? Message ATCB. Account keys, different. This thing. Come on, Andy, why did it take you that long to figure that out? Apparently, I'm already tired. That means my understanding of stuff was okay, but for some reason, I forgot that I have a random key pair here. Okay, one more time. All right, so doing this again should yield in the same goddamn message and the same goddamn transaction. Thank you, finally. Okay, now we can compare stuff. All right, same. And then we sign this message. We get signature 3BC. With Solver, same message. So nice, approved transaction. And here I get 376. It's a different one, even though the message was the same. So apparently Phantom does do something with it. One more time, I'm gonna try Backpack. Same message, approve. Here also 376. So Solflare and Backpack give me the same signature. Phantom does not. Phantom does some magic to that to keep it safe, which is great. I don't know what it does. Can request the user signs a given message. Applications are free to write their own messages, which will be displayed to users within Phantom's signature prompt. In order to send a message for the user to sign, the application must provide a hex or UTF-8 encoded string as a uint8 array. Request that the encoded message is signed via the user's Phantom wallet. To support sign-in with standards, applications that rely on signed message for authenticating users can choose to opt in one of the various sign-in with standards. You can read more about them here. Sign in with Solana. Solana example. Solana mainnet public ID. See, and it adds a nonce and the issued adds both a nonce and a timestamp, just to be sure. And that whole thing is added as the message. That's the sign in with Solana, just a standardized way how to do the sign in. At least I'm learning some stuff. So this is a proposal and apparently not an accepted proposal, which is super weird that it's just in the docs like this. So yeah, apparently this is not implemented with the Solana off-chain. So we rely on the wallets that they don't allow us to sign stuff. And we've seen different strategies. Glow doesn't allow it at all. Backpack just accepts it and would sign it, and then we have a valid transaction signature. Phantom does something nice that I couldn't figure out what they do, but in the end they result in a different signature that is not valid for the transaction. And Solflare just displays it as if it was a signed transaction. So that's also an okay strategy. So all the wallets handle stuff differently. Approve. Signature verification failure. Nightly also gives me a signature verification failure. I don't know. They do something. All right. But in any case, we're gonna end this here. It wasn't the video that I expected to make. Like, the learning here is signed message is actually almost as bad as signed transaction. Like, it's almost the same thing. And to some wallets, it is the same thing. So signing a message is not actually much safer than signing a transaction. In some ways, it can be more dangerous actually, because you don't know what you're signing. Solflare does a good job. Other wallets protect that you can't use it as a transaction. And I couldn't figure out why yet. So that I'm still like, we still need to talk about this in a future video. But for now, I guess my message is don't sign with a web page that you don't trust. Don't sign anything where you don't know what it's used for. And I wanted to, in the end, just tell you, well, message signing is safe unless you use it in an application like Elusive, where they rely on the message signing to then authorize your private balance, right? Because you don't sign a transaction there, you sign just the message, and then Elusive will allow the sending of a transaction on your behalf just because they have the signature for a certain message. So in that case, you need to be careful with signing messages in any case. But I thought that they can't be used to actually create transactions and sign transactions. But as I learned today, they can be. So yeah, stay safe out there. Don't sign stuff that you don't fully understand what it's doing. Good, and with that, I'm gonna end it. It's a bit more of a sad ending than I hoped it would be. I hoped there would be a clear, yeah, and this is message signing. But no, it's like, it's literally the same as signing a transaction message. But good that I did it, because now I know. Because recently on Twitter I was like, no, signing messages is safe, because I believed that proposal. And I believed that that was the standard, but it's not. So yeah, documentation that you find versus reality, two different things. Yeah, always try stuff out. Damn, wow, okay. Good that we played with it, we learned something, and it wasn't the thing that I expected to learn. But it's okay. Now check out those. Subscribe, like, and be ready for another video on signing. Because still some stuff that I don't understand and want to understand better. And I can't do it all in one day. My head is already exploding and I need some breakfast first. Yes, breakfast at 3 p.m. That's my lifestyle. Bye bye.